Okay, so I think a lot of you guys know Cameron Ecker. He's one of the ES50 TFs, and because, of course, we're in the middle of final project planning week, Cameron's ES50 project is up here in the front, and he's going to talk about it for a few minutes, and then you guys can ask him questions, and then we'll go into sequential logic, which is the topic for today.
And sequential logic is actually kind of the basis of this whole project, so it'd be kind of good to pay attention to that. So again, yeah, my name's Cameron. I'm not going to spend very long talking about this. I want to kind of see if you guys have any questions, but this is the project that I did last year. This is kind of a remake of that Chuck E. Cheese game, Vortex, or the original game was called Cyclone. We made a new version of it sitting right up there. It's pretty true to the original spec. I have a bunch, the slides pretty much are all pictures. So I'm going to kind of go through what the design process looked like, what sort of circuit we use. It's all stuff that, if you guys remember the lab last week with shift registers, this is pretty much all that. Oh, I have a quick video. So if you guys haven't seen this game before, this is, all right, we'll see if we can get the video up. This is just a YouTube video of someone playing the original one inside of Chuck E. Cheese. It's got the light going around. The idea is you want to stop the light on the jackpot by hitting that button. Pretty straightforward electronics project. Weirdly addicting to play. So take a quick look at the video. So light's going around, he puts in the coin, starts going the other way, and he's going to try to hit the button. And any second. And missed it by a little bit. But that's the basic idea, just that's what you see here. The version that we have is totally functional, does exactly what that one does. Even has some of the original timings from the first one, which is kind of cool. So back to the slideshow. So kind of going into project design. As I mentioned before, everything in this project is stuff that we pretty much repurposed the shift register lab, used a lot of the logic from that, and just made it a little bit bigger. The basic premise is we have a total of 78 LEDs on that board, and we wanted to be able to light them up, kind of pick which one we wanted to light up and do it in a controlled way. So obviously Arduino is kind of the heart of it. Arduino is the processor behind it, and we just needed a way to light up these 78 unique LEDs. Again, the scale, it's a pretty big scale. Really, it can be reduced to, there's 3 jackpot LEDs, one on each third of the board, 24 LEDs in between, and again, light up the right one at the right time. In terms of any unique parts, almost everything on that board we kind of found in lab already. There were resistors for the LEDs, there was the shift registers, there were the buttons, stuff like that. The only things we had to order is the acrylic, which is the sort of plastic that makes up the board, and the big LEDs. We used, these are, I think they're 1 centimeter LEDs, which is a lot bigger than your typical small ones. The original actually used incandescent bulbs, so this is kind of the next best. LEDs are more modern, a little easier to work with. Here's some of our original drawings. So I guess you saw it, but I didn't really mention it. I was kind of one of the members of the team. 2 other guys, Kyle and Bala, also we all worked together on this project. Here's a drawing on the left kind of laying out how we're going to do the lights in relation to the shift registers. Diagram on the right is kind of how the shift register works. We're kind of checking all the pins, make sure we hooked up the right things. These are just some sketches from kind of the early stages of the project. We go forward a little bit. The board, you'll notice if you look closely, the board looks a little complex. These are drawings in SolidWorks, basically kind of figuring out the inside diameter. It's a big donut. So the inside diameter, I think we had 11-inch radius and then a 14-inch radius on the outside. Again, these are all parts that we laser cut. If you want to laser cut parts for your own project, I did a lot of it for this, so you can probably talk to me. A bunch of the other TFs also know how to do laser cutting. But that was kind of the more complex part of the project, hardware-wise. Hardware not in the electronic sense, but in the building that ring so we'd have something to put the LEDs on. These are kind of what the CAD drawings look like back when we did that. So onto this, well, this is one more picture. This is after printing the first third of the board, getting a sense of what it would look like, and some of the LEDs are in place. Now, with these final projects, they're not all going to look beautiful when you go to present them. What mattered for us is we got it working. Here's kind of what the circuit looked like for a third of our board. Not very glorious, but you can kind of see some of the parts on there are things that you've seen before. Does this have a laser pointer on it?
Yeah, the green button.
Awesome. So these right here, that's a shift register, that's a shift register, that's a shift register, and we have the resistors to help make sure the LEDs don't burn out. So shift register and its resistors, shift register, its resistors, shift register, and its resistors. This is a third of the board. This basically just lights up 24 LEDs. It looks really complicated because we were very bad at making our wires neat, but in principle and function, it does what the previous lab did. We just have 3 in a row. So we did 3 shift registers for a third of the board, 3/3 of the board, 9 shift registers for sort of the ordinary LEDs, and 1 shift register just to do the jackpot LEDs. This is what the project looked like about 4 a.m. the night before final presentations. Chris was there. It was pretty incredible. We kind of took over one of these tables up in the Maxwell Dorkin lobby. But in essence, it's, again, not too complicated. Shift registers, another block of them, another block of them. Arduino's right there, and we have some of the kind of putting everything together logic. You'll see we have these buttons here. Another aspect of the project was figuring out how you can press the button, and when you press the button, you freeze where the light is. So that was basically configuring one of the pins on the Arduino to be sort of a read-in, so we could, in the program, access whether a button was pressed as just like any other variable. That was really the complexity of the project from the digital standpoint. This is what it looked like pretty much the day of the presentation. It wasn't very beautiful, but it worked, and I think a lot of people had a lot of fun with it. A little bit later on, this is just this semester, maybe 2-3 weeks ago, pulled the project out of storage, took a look at it, and tried to clean it up a little bit. Now this is what, in a perfect world, if you had time to do all the cleaning up, this is what I would have done last semester when I took the class, but this semester, just to make it look kind of nicer now, this is what we did. All these wires, we wanted to make this set, this board right here, into something a little smaller. Turns out you can reduce this block into just this block. These ICs on the left, these right here are the shift registers. The ICs on the right, turns out there's a chip that's a very, what is it called? Multiple resistor network. So in other words, inside this chip, from one side to the other side, it's just a 330 ohm resistor, and you have 8 of them. So it actually made it really, really easy to, instead of this messy thing, just use a chip and then tie them directly together like that. So built 3 of these, replace that, replace that, replace that. The finished product, what you see is the one in front of you right there. Thought I had another picture of it, but yeah, this is the final product. If you guys come up, get a chance, I guess maybe after lecture or whenever there's a chance, you guys can come up and play it. I only brought one of the buttons. There's usually 3 buttons, but the idea is the light goes around and you want to stop it on the jackpot. It's not easy. We actually managed to find the original manual for the game online. The company is Ice Entertainment, and they kept records, and they have the original manual. And this game was rigged, if you guys ever played it as kids. It turns out it was rigged. These ordinary LEDs, the ones that are not the jackpot, are on for 18 milliseconds each. Jackpot light is only on for 2 milliseconds. So you gotta hit it right on that 2 milliseconds, otherwise you're gonna miss it. On this game, it's identical timings. So if you guys want to try your luck on it, it might be in lab a little later on too, so if you guys want to play. But yeah, that's pretty much the technical side of it. You guys have any questions about the project or the process, anything like that? Yeah.
How did you come up with this idea? Like, where did you start with that process?
The hardest part of these final projects is figuring out the idea naturally. Where we kind of got this idea from was, it's a simple prospect. It's just light up a bunch of LEDs. We just wanted to make it addicting. We wanted to make something fun. We wanted to make something kind of unique with that. I'll say it again. The concept is really, really simple. It's just light up a bunch of LEDs and stop when you hit a button. But kind of remembering that's a good framework. There's actually another game. If anyone wants to take on this project, do you guys remember there was a game called, I think, Stack It Up or something? It was a big board with a bunch of squares. And you'd have a string of squares go back and forth, and you'd hit the button, you stop the squares, and then you go up a row, and then the squares would go back and forth. Anyone remember that game? It would be really cool to see someone make that game. That one is, in essence, it's a similar principle to this, but another simple concept. It's LEDs, buttons, stopping them, but it's kind of in a good package, in a game that's fun to play. Other questions? Yeah.
How long did you spend on this project?
Yeah, so how long did I spend on this project? It took quite a bit of time. This is probably a more time-consuming project. Maybe a third of the time was spent cutting the board. It took a lot of time we used Autodesk Inventor and SolidWorks to make the board. So maybe the first, I think we had, if we spaced the timing over about a month, the first week and a half was getting the board set up, ordering the parts. These LEDs, turns out you can't just get them from SparkFun, you have to get them from eBay. So we found a really sketchy vendor and managed to get the LEDs off eBay. The logic part of it was just kind of being careful. We got really good at wiring because you connect one data signal one pin too far to the left and everything breaks and you have no idea why, and you got to go back and make sure you get it. So yeah, about a month total. We started right around, it's almost the start of November, right? I think I approached the 2 other guys and we got together with the idea right around the start of November, right around now, and just kind of chipped away at it throughout the month until we got this. And we got it 4 a.m. the night before it was due is when we got it working. So we weren't too good on that respect, but yeah. Yeah.
What kind of breadboard is this? The smaller one? Does it have the same sort of structure as the breadboards we use in lab?
Yeah, it's a good question. The smaller breadboard you see on the right, it's actually, in this one, it's called a perf board. It's different in that, so the breadboard, you just plug things in, and then each row is connected. On the perf board, it has all the holes just like a breadboard, except there's no internal connections. In other words, every chip, so kind of right in here, between those two rows, on the opposite side of the breadboard, I actually soldered and soldered 2 rows together, so basically manually connected them. Again, that's only because I had time this semester. I worked in lab just to make it a little cleaner. For practical purposes, soldering is only if you have a part that really needs to stay together, and if it pulls out, the whole thing is destroyed. That's the time you should solder. You can get away with using breadboards for the greater amount of the circuits you build. That way you can troubleshoot a lot easier. Yeah.
I have a question about the process of the project. Like, what are your main takeaways from like using drones? Like, this you should for sure do throughout the project, or for sure don't do this. This is a bad.
That's a good question. One of the things I can say, kind of in relation to the previous answer too, don't get too jumpy with soldering your project. Make sure it works. Every step of the project, kind of go piece by piece. Make sure this piece works, and once that piece works, don't touch it until the next piece works, and then you can test backwards. Kind of, you want to be constantly testing. That way, the worst approach to the project is build everything and then test it the night before, because something's not going to work more likely than not. And now you got to go through every single piece and figure out where the problem is. In terms of things to do, definitely split up the work among people in your group, and make sure each person kind of give each person their sort of area that they want to be the expert of. But at the same time, have everyone know what they're kind of working on. So on this project, we had one of the other guys, Kyle. He was in charge of setting up all of the in-between lights. So he knew he had a special convention for how to notate which was the positive side of the LED, the negative side, and he kind of controlled that part, and it turned out well. I did a lot of the programming, so I just kind of each person kind of knew what they were responsible for, and that worked really well for getting the project done. Yeah. Cool. If that's everything, yeah, I'll pass it back to these guys. Thanks, guys.